Hello students, today we are going to start with this new chapter called sound. Now this is a term which need not be given any explanation because the sensation of hearing for human beings is because of sound. So what exactly is sound? See, sound is a form of energy. So it gives us the sensation of hearing. But what exactly sound is, how is it produced? We are going to know the technical terminologies associated with sound and everything we are going to study in this chapter. Let's start with this thing. The first thing is that the sound is produced due to vibrations of the objects. This is the most important point for the cause, because if there is energy, for example, heat is a form of energy. So random vibrational, translational, kinetic motion of molecules or atoms gives the production of heat energy, or some sort of chemical exothermic reaction gives us heat energy. So every energy has some source. So here if you are talking about sound energy, so sound energy must be produced by something, and it's not like that this energy is being generated out of nothing. Every energy actually takes form of some other energy. So sound energy is derived from some other energy. For example, light to sound, then mechanical to sound, and lot of stuff. For electrical energy to sound, this is the most common example you can relate with, like loudspeakers, microphones. Sound to electrical and electrical to sound conversions are very easily you can watch it in everyday life. Now sound is produced due to vibration of objects. Okay, I want to interrupt here and I would like you to note all the key points of this chapter, because this is very much of a theoretical chapter. So instead of me explaining you everything, you should make your own notes, and that is why I have provided you more notes in this chapter as compared to the other chapters, because you have to make your own notes. Alright, so sound is a form of energy. Sound is produced due to vibration of objects. Right now I am speaking and you are listening. So my speaking part, the sound is coming from the vibration of my vocal cords, which is inside here. Now vibration is the rapid to and fro movement which we know. Now a stretched rubber band, this is an activity you can do. You can take a rubber band, stretch it, and ask someone to pluck it from center. When it will be done, you can hear the sound. So that vibration produced sound. Yes. So this activity is to show that vibrations produce sound. And how does they do so? Strike the prongs of a tuning fork. Suppose I have a tuning fork in my hand, I strike it on the table and I place it very near to a hanging bob. Bob is basically a small metal ball. Okay, so it is very close to it. So when it starts touching it, the vibrations produce continuous sound. So this continuous vibration produced a continuing sound. This is what activity which can be done. Now how sound propagates, that's the second feature we should know about, that how sound travels from one medium to another. For now, during online conversation, suppose you are doing a video call from your home to your parents or to your grandparents, anywhere, the sound basically which is being emitted from your vocal cords is getting tuned into some other form, like electrical by microphone. It has been then converted into electromagnetic wave by the various complex machinery present in your mobile phones, and then electromagnetic wave is sent in space to other device, and there it is reconverted into more modulated form, which is again sound form. So loudspeaker takes that energy out. So sound energy is sent through this channel, the kind of communication channel. But if we generally talk about, suppose you are standing right in front of me and I am speaking here, you are listening. So how the sound is traveling? Sound needs a medium to travel, and sound here between you and me will be medium, would be air. So sound, it's not like that sound travels only in air. Sound travels in all kind of medium, solid, liquid and gas. So sound needs a medium, because this is a mechanical wave, and mechanical wave, I'll tell you about what's mechanical wave and what is the medium thing. But basically medium is the whole vacuum filled with, suppose the space filled with something between you and me, if you are present right here. So the space right now is air, so the air is the medium. So solid, liquid and gas, these are three type of mediums you already know. So sound travels in each medium. When an object vibrates, the particles around the medium vibrates. These particles then collide with the neighboring particles and they start vibrating, and hence they will start vibrating and they will collide with the particles neighbor to them and they will also start vibrating. This starts kind of chain reaction. So particles starts transmitting their energy from one to another in to and fro movement. Okay, and that is how sound travels. That is why sound needs a medium for propagation, because they are transmitting the energy from one particle to another. Okay. The disturbance produced by the vibrating body travels through medium, but the particles do not move forward themselves. This is again very important point. For example, consider that this place is filled with water. I am throwing pebbles in it. Okay, ripples will get created. Now ripples start moving from center to outward direction. They form a wavefront like particular circular wave, and they'll start moving in outward direction. Now when that happens, do one thing, do one activity. Throw some matchsticks on water, on stagnant water. Take your bucket, fill it half with water, pour some matchsticks on it, and then drop some pebbles smoothly. When the ripples will be formed, ripple will cross the matchstick. Matchstick will go up and down for a moment, but it will not go along the wave, because the waves are formed in this way that they only are acting as a medium of transfer of energy. They are not transferring themselves outwards. They are transferring the energy. That is what these particles do even in the propagation of sound. If my vocal cords are vibrating, which is producing sound, then the sound energy is transmitted from this particle which is nearer to my mouth to next particle, and then next to next to next, and this is how sound travels. But the speed at which these vibrations are carried forward from one particle to another is super fast, and that is why speed of sound is very fast. You know what is speed of sound? What is the term which is used for speed of sound? Okay, have you heard that aircrafts have used, they cross a sound barrier called Mach speed? Basically, Mach is the speed of sound, Mach 1, Mach 2, and 330 meter per second generally used in calculation is the speed of sound in air. But as I already told you that sound needs medium for the propagation, and if the sound is traveled in a manner that one particle is transferring the energy to neighboring one, then the neighboring one, and then so on and on. So that means if sound is to be traveled in a medium where particles are more densely packed, like liquid and solids, in gases particles are not densely packed, but in solids the particles are super densely packed. So sound will travel even faster in solid, and that makes sense, and that is absolutely true. Sound travels fastest in solid, then in liquid, and then in gases, because of the distance between the neighboring particles which are carrying energy from the source to the observer. Let's move on. Propagation of sound through air. This is how sound propagates. Now when the particles are transferring the energy, these particles which are taking the vibrations forward, each particle is not just transferring the energy and putting back to rest. No, they are still vibrating because they have some energy. So this particle started vibrating, this particle started vibrating, and they are transferring the energy further. But at some point during vibration, they are very close to each other and they are very far to each other. So these are called compressions and rarefactions. Compressions when they are very close, rarefactions when they are far. So let's move on. Let's read this paragraph. This is how I have already explained. This is how sound travels in form of compression and rarefactions. Air is the most common medium through which sound travels. When a vibrating object moves forward, it pushes and compresses the air in front of it. We are talking about the particles of the air medium, forming a region of high pressure, which is called compression, where it is close and the compression moves away from the vibrating object. When the vibrating object moves backward, because after every compression it will be coming back, so it forms a region of low pressure, which is called rarefaction. That is, these are compressions and these are rarefactions. As the object moves to and fro rapidly, it produces a series of compressions and rarefactions in the air, which makes the sound to propagate from source to observer. Now, what should be the next point of our study? We have to prove whether the sound actually travels in medium or is it just a myth. We'll do that activity. But first, this is a vibrating object producing a series of compression and rarefaction. So this is how it is shown. You have to start from figure 1. The tuning fork, which was given a head, started vibrating. It produced compression, and then compression is followed by rarefaction, and then that rarefaction is followed by compression, and again rarefaction, then compression. So this is how it is traveling forward. So this is what you have to see: compression, rarefaction, and so on. This is how sound propagates. Okay. let's study about the activity which will prove that sound needs a medium for propagation. The activity is very simple. We have taken an evacuated glass chamber and it is connected to a vacuum pump so that no air is in this glass jar. Now we have placed an alarm clock in it, and when alarm clock goes out, that means when the time is hit and starts turning on the alarm, we will not hear the sound of alarm because there is no medium to carry that sound energy to outside the jar, right? So basically sound needs a medium. So glass jar is, because we have already evacuated it using the pressure pump of vacuum, so there is no gas molecules which are present to take that energy and vibrate it to the needle outside the glass, right? So that is how this proves. This activity can be easily done even at home. You can take normal vacuum cleaners which are present at home and offices, and you can connect it with a glass jar and put some pebbles in it, okay, small pebbles, and don't take super strong because it will implode, not explode, implode the glass bottle. It may be very dangerous. So please do this activity only in the supervision of your adults. Now when those glass pebbles are shaken, you won't hear the sound of the pebbles because you can only feel the shaking of pebbles because of their mechanical action. Otherwise you won't hear it because there is no gas and there is no air to take that sound out of the medium. Alright. Now next, sound waves are longitudinal waves. This is the point we are coming to. There are two types of waves. Okay, first of all, what is wave? Wave are the locus of all points which are at same energy phase. Now this is a definition which is not mentioned here, so you should write it down right now. Waves are the locus. Locus means group of points, set of points. So waves are set of points which are at same energy phase. Reimagine my diagram of, suppose this is the water and I am dropping pebbles here, this is creating ripples. So take each ripple, that is a wave. Okay, so wave is basically, waves are basically travels in the form of wavefront. One whole circle would be one wavefront. So waves are actually the shape and the carrier shape, basically I should rather say carrier shape of carrying the energy forward. So waves are of two types. One is called longitudinal, one is called transverse waves. The difference is, in transverse waves, suppose this is the direction of propagation of wave, then the direction of vibration of particles would be perpendicular to it, perpendicular to the direction of wave. So that is transverse. Whereas in longitudinal wave, if this is the direction of propagation of wave, then the direction of vibration of particles would be along the direction of propagation of wave. That means if wave is going in this direction, the vibration of particles will be in this direction. Whereas in transverse wave, this was the wave and the direction of propagation is perpendicular, right? So activity is, do you know what slinky is? Slinky is a toy, basically very long, soft, elastic spring, and that slinky, stretch it and keep giving it repeated pushes. So that will create compressions, and that compression due to the elastic nature of spring will be forwarding and leaving behind a rarefaction. So these compression and rarefaction, they follow alternate in order, and this is how you can see that this is how sound also travels. Okay. Now, what are the characteristics of sound waves? Characteristic, we are going to talk about those technical terms which will help us understand this topic better. Sound waves can be described by its frequency, amplitude and speed. So these are three main characteristics: frequency, amplitude and speed. Now first of all, as I just told you that in transverse wave, the direction of propagation and vibration of particle are in perpendicular direction. This is what it was. This is the direction of propagation of wave, whereas the direction of vibration of particles perpendicular. Whereas in longitudinal wave, it is same direction, and the compressions and rarefaction, vibration is in along the same direction. So first of all, you should know about what is wavelength. Wavelength is the, okay, before going to wavelength, here you know that these are compressions and rarefactions, but here these are called crests and troughs. Crests are the upper side, troughs are the lower side. One crest and one trough together makes one complete wavelength. So this is one wavelength, this is second wavelength, up to from here to here, this is third wavelength, and so on. Similarly here also one compression plus one rarefaction, this is one wavelength. Okay. So why are we talking about wavelength if we have to study frequency, amplitude and speed? Because they are all interrelated. Now this thing is clear, crust and trough. The distance between two consecutive compressions or two consecutive rarefactions is called wavelength. Distance between two consecutive troughs or two consecutive crusts is a wavelength, or just take one crust and one trough, that is also the wavelength. Frequency. Frequency generally means number of vibrations happening per second. So suppose one complete vibration, we have to talk about one complete. So if I'm starting from bottom, I have to finish at where? If I'll be starting from 0, upper 0, lower 0. So here this is one complete wave. So suppose this wave is making this 5 cycles. One cycle means one complete crust and one complete trough, or one complete compression and one complete rarefaction. One cycle means. So suppose this wave is making 5 cycles in 1 second. So, and this cycle is making only 3 cycles in 1 second, which is of higher frequency. Number of cycles per second, this one, okay. So short wavelength. Now how frequency and wavelength are interrelated? I told you that distance between two crusts is a wavelength. Here also distance between two crusts is a wavelength. So here it was higher wavelength but frequency is low, where it is lower wavelength but frequency is high. So they are inversely proportional. Frequency, I'll give you this diagram. Frequency is inversely proportional to wavelength, and the product of frequency and wavelength is called speed of that wave. So you just note down this formula. Speed is frequency times wavelength. Now the next part,